Alright, so we're going to look at oxidation numbers. So we're talking about ionic and covalent compounds and what is happening to the electrons in the oxidation numbers. So what type of charge or what is happening to the electrons. So first we're going to look at ionic bonds. And ionic bonds are when we have two oppositely charged ions bonded due to the electromagnetic force. And keep in mind, opposites attract. So we did learn about this in our last unit, just to get our feet wet in the topic. So an ionic compound is a chemical compound made of ionically bonded ions. How are ionic bonds composed? How are they made? We are looking at elements on opposite ends of the periodic table. So part of our ionic compound are metals and the other part are nonmetals. So the metals have 1, 2, or 3 valence electrons. They are loosely held in the outermost shell or the newest shell. And those electrons have very low ionization energies or electron affinities, so they're not really bound tightly to the nucleus, so they're easy to get rid of. And then the nonmetals have 6, 7, or 8 electrons held tightly by the effective nuclear charge. So they don't want to lose any electrons. They're hanging out there pretty tightly and want to stay with their atom. So when the two atoms come together, the nonmetal grabs electrons from the metal, making itself a negative ion and making the metal a positive ion. So with that loose connection to the nucleus, the metal just gives up its electrons, and with the nonmetal having that strong force, it's pulling those electrons to it. So the ions are now held together by the electromagnetic force. The number of electrons an atom is willing to gain or lose is called its oxidation number. So we've been calling it charge and giving it a positive and negative number and saying, what is that atom's charge, or what does it become, what's its charge? So we're actually talking about oxidation numbers. There is a pattern on the periodic table for those non-transition metals, meaning the families that have the Roman numeral in the A for their columns. So column 1A has a +1 charge. Column 2A gets a +2 charge. Column 3A gets a +3 charge. Column 4A, or 14 on the periodic table, has a positive or -4 charge. And then column 15, or 5A, gets a -3 charge. Column 6A has a -2 charge. And column 7A has a -1 charge. So respectively, we go 1, 2, 3, 4, 3, 2, 1, with the left side being positive and the right side being negative. When we look at writing these or expressing them to show that they are ions versus neutral atoms, we do use superscripts. So superscripts are placed to the right of the atomic symbol to indicate the magnitude and sign of the ion's charge. So basically we're saying here, hey, it has an oxidation number. So calcium is in column 2A of the periodic table, so he gets a +2 charge. So calcium is a +2 ion. The positive superscripts are for atoms that have lost electrons, and the negative superscripts are for atoms that have gained electrons. Keep in mind, we're saying electrons. They're gaining or losing electrons, and electrons are negatively charged particles. So if you lose something negative, you become kind of happy or a little positive. If you gain something negative, you become negative yourself. So we're talking about that exchange of particles. We're not talking about mathematical numbers here. Now let's take a look at covalent bonds. When we have covalent bonds, we have two atoms that bond together due to sharing of electrons. So the covalent compound is a result of that, or we call it a molecule. So you have a compound that is a chemical compound made up of covalently bonded atoms, the definition of covalent compound. So sharing, sharing, sharing. And how do we get that? We get that from elements that are on the right end of the periodic table. So we have two or more atoms that are on the right side and they decide they want to hang out together. So the nonmetals with 6, 7, or 8 electrons are held very tightly by that effective nuclear charge. So they don't want to give up to another guy who is close by. So the end result is when they come together, neither nonmetal is willing to give up its electrons, so they must share electrons to become stable. So once again, we're talking about covalence and sharing, and we are looking for that stability. The atoms are now held together by the effective nuclear force between the shared electrons and the two atoms' nuclei. So they are both strongly attached to themselves, but yet they can share a little bit with the atom next to it. So the number of electrons an atom is willing to share is called its oxidation number. So we're talking about electrons involved in bonding. So in covalent bonding, we're talking about sharing. So the sign is assigned to it. So the elements that are more to the left get a positive sign, and the elements more to the right get a negative sign whenever we have two or more atoms sharing. So superscripts, once again, are placed to the right of the atomic symbol to indicate its oxidation number. So oxygen by itself would have a -2 charge. And then when we look at it when it's combined with another atom, so like carbon dioxide or carbon monoxide, whichever one you want to talk about, carbon would get the positive charge because he's further to the left, and he has 4 electrons he's willing to share. And then oxygen, there's 2 of them in this case. Each oxygen has 2 electrons they're willing to share. So oxygen by itself is a -2, and when it's sharing, it's also -2. And this can change a little bit. We did talk briefly about resonance structures and some other things, but we'll save that for a later date. So to wrap it up, we have superscripts also. So the positive superscripts are for atoms more to the left, and negative superscripts are for atoms more to the right. So whether you're talking about ionic bonds or covalent bonds, the item that is further to the left will get the positive charge or oxidation number, and the item that is further to the right will get the negative oxidation number or charge. So we'll have in class some formulas written down that you can practice oxidation numbers. The expectation is that you'll be willing to try them out, and then once again we'll go over them in class to make sure we're all on the same page. So have a good day.